everyone, and thank you for attending today's webinar, Bridging On-Premise and Cloud-Native Infrastructure with Secure Application Delivery Strategies, sponsored by A10 Networks. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of the audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading Senior Analyst Jim Hodges. Jim?
Thanks, operator. So welcome everyone to today's webinar, which is entitled Bridging On-Premise and Cloud-Native Infrastructure with Secure Application Delivery Strategies. My name is Jim Hodges, and I will be your moderator today. So today we've got a really interesting topic for you. We're going to be really addressing and documenting how changes in application delivery from on-premise to cloud-native and hybrid cloud architectures are really, I think, impacting the role that application delivery controllers play. So let's take a look at the agenda. So in terms of the presentation structure, we're going to start first by looking at how the model of delivering applications is really changing. So we'll also include, obviously, a strong focus on the impact of application delivery controllers, or ADCs. And then we're going to present a number of use cases that tie together the role that ADCs play in this new application delivery model. And then we'll also provide an overview of A10's ADC portfolio and how it's evolving to meet these new application delivery requirements. We'll also have time to take your questions at the end, as we always do, and we'll also be conducting 2 poll questions to get input from you, the audience, into kind of a number of the key topics that we're going to be discussing. So let me start first by introducing today's speaker. So joining me today and presenting is Brian Meckley. Brian is Senior Manager of Product Marketing at A10 Networks. So welcome, Brian.
Well, thank you, Jim. It's great to be here.
Okay, before we start, Brian, before we dive into the presentation, why don't you tell us a little more about A10 Networks?
Yes, thank you, Jim. So for the webinar attendees who are not familiar with A10 Networks, A10 was founded in 2004 and became a publicly traded company in 2014. We are a global company with over 850 employees located in 27 countries, and A10 currently has over 5,000 customers spanning 72 countries. A10 provides application delivery, security, and carrier-grade products and solutions to service providers, enterprise, and web giant customers.
Okay, great. Thanks, Brian. So let me start here before I turn the presentation over to Brian. I do want to have some sort of background discussion on the role of ADCs in secure application delivery. So really, as I said, the focus of our presentation today is really to examine how the changing model of application delivery is really driving a change in the evolution path and the role of ADCs. So on this really high-level diagram, what I wanted to capture is I really captured both the models. So on the bottom is the traditional ADC model where it's deployed on-premise in the data center, and then on the top as well we have the virtualized ADC or VADC running in either public or private hybrid clouds. So really the key point that I wanted to make is that really in both architectures, an ADC or virtualized ADC really performs pretty much the same basic functions. This includes really vital functions such as load balancing of traffic and of web and application servers, so load balancing traffic for them both. Also application health monitoring, things like SSL acceleration, so this is able to offload the requirement for web servers to perform encryption to the ADC. And of course there's other applications, other functions and applications as well, in things like caching and compression of content, and even things like HTTP security support. So, I think as you look at this, the key point I want you to take away from the slide is that ADCs are really vital to both models. They can, either if they run natively in the cloud to manage web server and application resources, or on the premise or on-premise in the data center, they really support these functions. And going forward, as we move to the cloud-native solutions, the ADCs will perform also a very strong role, just as ADCs, traditional ADCs, have done for more than a decade. So I do want to talk about the cloud model first a little bit more, because that's obviously the focus of today's presentation. So, as I said, there are a couple of factors that I see that are very much reshaping the role of ADCs. So moving just beyond the basic functions that I've described. And I think is the first that you have to look at it is just really the nature of the applications themselves. So the first is that applications fundamentally change in the cloud model. I think everyone knows that as we move to the cloud, applications become purely software-based and virtualized. So they're really effectively, I would say, decoupled. So they can really pretty much run on any sort of specific web server. And so there's really a much greater degree of flexibility to scale these applications, and it's obviously a key reason to move to cloud-native applications. And as well, since we can run these applications pretty much anywhere in the cloud, what we're seeing is a move in industry to move those applications closer to the end user so that they're really more agile to deploy, since there are no specific hardware requirements, and even probably increased performance, lower latency, things like that. So, very important to do that as well. And I think there's other applications to consider here as well in terms of, we're very much on the cusp now looking at and moving to a cloud-based microservices model, and obviously microservices are important because it'll drive further agility and even automation because we're able to reuse a number of software models. So when you factor in microservices, that really is also another factor of how the application delivery is changing. And as well, I think we also have to look at also, the impact of open source applications. As we move to the cloud, there's been a lot of discussion as an industry in the last 2 years about open source, and we're seeing that move very much forward in terms of, the shift to open source applications where there's a greater use of third-party developed software. And I'd also say that you have to think about it in terms of the cloud is very much more analytics-driven than in the traditional data center model. So there's a lot of new opportunities, even like service opportunities, to make application delivery much more personalized on an individual subscriber level. So I think that part of it is very important as well. And we'll talk about analytics as well. And I think also security, given applications can be deployed in public or even private or even hybrid clouds, there are a number of new security challenges that are introduced, and really I think considerations that you have to factor into your strategies when you decide to move to the cloud and deliver applications that way. And Brian's going to be covering these points in more detail. But before I do turn the presentation over to Brian, I do want to just go back to this diagram and really stress that, regardless of the architecture, whether it be in the data center or in private or hybrid clouds, there's really a requirement to run both architectures for some time. There's obviously network operators have a considerable investment in data centers, and there's really not going to be kind of a time T or a flash cut of applications to the cloud-native model. It's going to happen based on the operator's time schedule and requirements and so on. So I would say that bridging both domains is crucial, and that's obviously something that's critical for ADCs to do. And because of that, I think there are a number of requirements for ADCs that we'll talk about in more detail. And I think first is the idea of traffic patterns. The traffic patterns of the cloud, be it private, public, or hybrid, can really be much more dynamic than data centers, which is why virtual ADCs, I think, are such a good fit. And I think, as I've also touched on, security and enforcement in the cloud can really be more complex because, as we're going to see, applications can be distributed. There's also more opportunities for third-party enabled software as well. So I think when you take that to consideration, there's a lot more to consider about how you actually secure and actually implement policy-driven security in the cloud. And finally, just a key point is from a customer perspective, I think is, despite these new requirements, the end user basically really expects that the on-premise and cloud models will be pretty much, I would say, identical, or maybe not identical, but seamless in terms of interface and application fields. So, this is something that obviously has to be accomplished by having software transparency between a traditional ADC and a virtualized cloud-based ADC. So with that, let me turn the presentation over to you, Brian. I'll push out your first slide, and you can go ahead and present the content. Thank you.
Okay, terrific. Thank you, Jim. So it's all about the applications nowadays. There is a huge growth in applications developed both on-premise and natively in the cloud, but more and more applications are now being developed in the cloud. So trying to make sense of all this. Now, users have new requirements and expectations, which are fast, simple, and secure access to their applications. But businesses need to be agile, and they need to be competitive, and it should be easy for them to scale. And IT is in the middle of all this, trying to figure out what type of infrastructure should be used to be agile, scalable, and secure. And on top of all this, operations should be simplified to address all these requirements. Now, as the benefits of the cloud emerge, how does an organization utilize the cloud while still leveraging the benefits of their existing on-premise architecture? And really, the answer is to bridge both worlds, utilizing the benefits of the existing on-premise data center model and the cloud-based native application model. All this needs to be done by providing a means to provision and manage centrally across both environments. So organizations should not be planning to completely migrate from on-premise solutions at this time, but embracing cloud-based application delivery as a method to increase agility and scalability. There are clearly advantages of both on-premise and cloud-native application delivery environments. Now, let's take a look at the application and delivery evolution. So the infrastructure is changing from hardware and software appliances to cloud-native application and service delivery. So applications are moving from traditional monolithic architectures to microservice-based, leveraging containers, where a lot of new app development is taking place today. And because of this, the DevOps process and application teams are becoming much more influential and relevant in the app tool selection and the application delivery method process. So agility is really the basis of the move to cloud microservices and the DevOps processes. Now, if we break this down a little further, the way applications are being developed and deployed is changing, along with the operations process and the overall business model. So applications, again, are moving from monolithic three-tier development, such as client-server-based, to microservices and containers, which are now cloud-native. Deployments are moving from on-premise data center to public, private, and hybrid clouds, transitioning from dedicated hardware to really to an ad-needed infrastructure basis. And operations is moving away from IT-led processes to DevOps, self-service, agility, and where developers have much more influence in how application delivery is used. And finally, the business model is also changing from purchasing appliances to using more of a consumption model, or said otherwise, buy up front versus buy as needed. Now, some of the application delivery challenges, if we look at both on-premise and we look at the cloud, on-premise uses hardware and software appliances and is configured and managed traditionally by the IT team. But there's really no agility that's being offered to the application teams. There are no self-service capabilities, and very little automation is being used. But if we look at the cloud, many of today's application teams would rather build cloud-native applications and just use open-source products such as Nginx and HA Proxy for their application delivery. They will need to actually combine different pieces of technology to collect analytics and provide visibility, which may not be included in the current open-source load balancing. And this will be built to complete the whole application delivery solution. And this is really what companies like Netflix and Uber have done. Vendors need to understand this and really bring this approach to the mass market, to the IT and the application teams, and package application delivery so it can be easily consumed. Now, if we look at the pure cloud model, where open source technologies such as Nginx and HA Proxy are used, additional layers, including security and visibility, need to be addressed and actually implemented separately. So if we go back to the example of the Netflix and the Uber, they can do this because they've recruited and built large DevOps and engineering teams. But when you think about the average IT team an organization has, they may not have the skill set or the capabilities to tie all this together and to accomplish this. And from a technology and business perspective, it may not be practical for a typical company to build this type of team. So what vendors need to do is provide solutions that bridge the on-premise and cloud environments to utilize the best of both worlds and provide this in a packaged solution to the application teams. So moving forward, application delivery solutions should provide a set of consistent services across clouds that can be centrally managed and pre-developed. And this provides the flexibility to deploy applications wherever it is appropriate in actual different cloud infrastructures. And again, what will be required are consistent policies and management across on-premise and cloud environments. Jim, I'll turn it back to you.
Okay, thanks, Brian. So we're going to stop here and conduct our first poll question. So what we'd like to, as we said at the beginning, what we'd like to do from the audience is get your input into a number of the topics. And the first one is really related to kind of the key points that Brian just made in terms of, challenges and migration or principles for migration of applications to the cloud. So the poll question is, what is the greatest challenge that you face in supporting cloud-native applications? Is it managing the scale requirements, managing the security requirements? Is it maintaining policy and service consistency across clouds? Is it OSS, BSS related in terms of network monitoring and provisioning of new applications? So while we're waiting, Brian, you made some interesting points about principles for migration. We're going to talk a little bit more about that. When you also mentioned containers, I'm just wondering, does the complex, I guess in some cases you're going to see that operators are probably moving to the volume, or they're moving to an application in the cloud. But are you also seeing that there's a lot of discussion now about building some of those new applications in using microservices and containers?
That is correct, Jim. So that seems to be the trend now, is to build applications directly in the cloud.
Okay.
And we'll talk a little bit going forward about the traditional applications today, migrating to the cloud, and then the whole idea of just developing the applications in the cloud. But that is clearly the trend today, Jim.
Okay, perfect. Okay, let's see what the audience said here in terms of input. Let's push the results out here. Okay, so actually quite a sweep for security requirements, 58%, and then the second one was OSS BSS, 21%, maintaining policy and service consistency, 17%, and 4% for managing scale. So any surprises here from your perspective?
Jim, this actually was pretty well about what I expected. And we'll talk a little bit about the security requirements. But as I mentioned before, when organizations are looking to build applications in the cloud, they're looking to migrate to the cloud. There's a lot of things that will be missing from what they're used to or accustomed to having in an on-premise environment. So these solutions will have to address security, and we're going to talk a little bit about that because that's certainly very important. When you move to these different environments, you don't want to leave something behind as important as security.
Exactly. Okay, so let's continue. I'll turn the presentation back over to you, Brian, so you can actually present the ADC cloud use cases that we talked about in the introduction of the presentation. So I'll push your first slide out.
Oh, I appreciate that, Jim, and I think it's important to go through some of these use cases. Now, there are many use cases, and there'll be plenty more going forward, but I wanted to cover just a handful of those today. So really, organizations are looking to take advantage of the benefits of the cloud, and many are currently building a hybrid of public and private clouds. Now, I've heard several estimates indicate that hybrid cloud adoption for the enterprise will near 50% in 2017, and that statistic does not surprise me. So this is not something people are just thinking about or looking at. Organizations, enterprise, service providers, they're looking to move applications to the cloud, as we just discussed a moment ago with that. Now, this does add complexity because, as we just discussed, moving to the cloud, there's a lot of tools that may not be there, new tools that need to be put in place. So there's certainly some complexity right now as organizations move to the cloud. And this could be just the management, security, as we saw in our poll. But the end goal, the agility, the scaling, the cost saving for any business really can make this effort worthwhile an investment. Now, vendors, on their part, they really need to help organizations remove this complexity and provide some prepackaged solutions for secure application delivery, including the services like the security that was just mentioned, and some other future services. Now, organizations, as they extend their data centers and start to move their services to public and private clouds, they're going to be implementing a more distributed hybrid cloud model, and there will be some requirements to interconnect these clouds, and that will be very critical to have communications between, again, public, private cloud, and on-premise data center. And application service integration with platforms such as OpenStack that we'll see in the private cloud will be very key to properly distribute and utilize resources. Now, even with the continued adoption of the cloud within the enterprise, many companies will still continue to support applications and hardware purchased and managed within the traditional data center. And this may be due to mission-critical applications that have specific performance requirements, applications that really cannot be moved to the cloud, security concern, or just the fact that the infrastructure is already in place, and management and operation processes are well known. So it'll take some time for the transition, but again, the goal is to look at the benefits and to kind of bridge these worlds and take advantage of both as the businesses look at their current infrastructure today. Now, let's just jump into some of these use cases. Now, the first would be the staging and testing environment. So a public cloud, as an example, can be used as a test environment before deciding when to actually run production applications in a multi-tenant cloud. And again, the point being that's a multi-tenant cloud when we refer to the public cloud. Now, the public cloud can provide generally a 20 to 30% cost reduction as compared to on-premise infrastructure application staging and testing, because many organizations will obviously purchase additional equipment, have different systems in place for their application development outside of production. Now, this actually gives the developers an opportunity to work within the cloud to really get used to the new tools and to the new processes that are involved with developing clouds natively, or excuse me, applications natively in the cloud. Now, as we look at this slide, you can see it's much easier to actually develop applications in the cloud natively than trying to develop them on-premise and then move them to the cloud. So in this example, we can see that on-premise, traditionally, developers will build a prototype, they'll build a beta release, they'll do some testing, they'll have an initial release. And at that point, if they want to push this application to the cloud, they're now looking for a cloud provider. They're looking to test or rebuild this application in the cloud before they have a full release and deployment. But by starting out in the public cloud, they can build their actual releases, the prototypes, up to the initial release, and then just deploy that. So it's a much easier and a process, and can also save a business money. Now, looking at disaster recovery. So when you think about the cost for an enterprise to maintain a backup systems at a disaster recovery site, it's actually a large cost, and it's seldom used. So when you think about it, a private cloud could be used to back up an on-premise data center, and a public cloud could be used and paid for as needed while providing some geographic diversity. So using the cloud for disaster recovery removes the need for data center space and dedicated infrastructure. And the ability to copy, spin up virtual hosts in a cloud and resume operations can actually be performed rather quickly. So although there are many considerations for using the cloud as a disaster recovery site, such as security, redirected access, it is now becoming a solution that many companies are considering. And what I've noticed there are several cloud providers today that are providing several options for cloud DR services. So I see that as a very good use case. And again, I've noticed that many providers are actually taking advantage of this opportunity and providing this service to customers.
Brian, just very quickly, if we just go all back to that use case for a second, it's an interesting idea in terms of being able to use those resources as you need them. When you talk to customers who are migrating from an on-premise to data center to either public or private cloud, I'm assuming that in a lot of cases they're looking to maybe the private cloud first to kind of give them replication, but also kind of geographical redundancy. Is that a fair assumption?
It would be a fair statement, but that's a little less dramatic, obviously, than moving directly to a public cloud. So that would also be kind of treated more of a secure environment. And also, when you think about it, Jim, if I am starting to look at supporting on-premise data center, I'm kind of building a private cloud that may not be a retooled on-premise data center, but maybe just another location, maybe a provider providing this service. I can use that as for other things besides disaster recovery. So I can start my application migration. I could use this instead of building another on-premise data center. And now I have this use that I could also use it for disaster recovery. So when you think about it, it's a really good cost savings versus a business looking for a dedicated disaster recovery site or service. Yeah,
no, agree. And the reason I ask that is because some of the research I've done recently in talking to operators and enterprises, one of the things about the private cloud that they like is it kind of goes back to that statement you made about enforcing kind of common policy and security is a little bit more, I would say, straightforward in a private cloud.
Absolutely.
Okay.
Absolutely.
Great. Thank you.
All right. Great. All right. Now, just moving on to migrating applications. So legacy applications are generally hosted in the on-premise data center or a private cloud. So those might be applications that are just not well suited to be running in the cloud, ones that are maybe being rebuilt to run in the cloud, but it's not uncommon that many applications will stay on the on-premise data center. Now, other application tiers and components can be migrated to the public cloud, for example, for cost savings. And in this example here, we have a front-end web application that sits on a public cloud where the back-end database servers are in the data center kind of behind the traditional firewall. And this would be a very nice method, again, to help with my application migration, but it may make sense for cost savings, just for diversity, for clients to hit a public cloud and then keep all of the other resources, the back-end servers, the databases, secure records, keep that into either a private cloud or to an on-premise data center. And organizations will need to rework, as I mentioned, their existing applications for the cloud or build them in the cloud. But overall, they'll need to really consider the best environment for their applications that they have today or their application components. So that this will take some time as migration happens, but I don't think it's a situation where all applications need to move to a public cloud, for example. There's always going to be situations where both on-premise, private cloud, and public cloud would make sense.
So, Brian, sorry, I don't want to interrupt you here, but in this example, this is quite interesting to me. Where you've got a web front end, is sort of the idea of migrating it in this way using public cloud. Is that because it really gives you sort of gives you kind of more service agility, application agility? Is that kind of the key driver for this?
So that would certainly be a key driver. And again, it may make sense depending upon the cost of having this web front end, having traffic go directly to the public cloud versus supporting that natively at the private cloud or on-premise data center. It could also, Jim, just be a stepping stone as applications are moving to a public cloud. Now, as we saw in the poll questions, obviously security is going to be a big concern. So I think this example really shows that it may make sense to push some components, like in this example, the web front end, to a public cloud. But there will be things like records, the database components that really should be sitting in a more secure environment at this time.
And one of the reasons I raised this question and I wanted to talk to you about is I could actually kind of see this model as actually pretty well suited to microservices as well. Would you agree?
Absolutely, Jim, absolutely.
Okay, great. Thank you.
All right, so let's take a look at another use case, and that would be scaling and workload bursting. So there's been a lot of talk about this recently. Now, the whole use of bursting to the public cloud to temporarily increase scale from the private cloud or the on-premise data center is actually not that common today as far as it being used, just due to complexity, the lack of system communications between the clouds, and the way applications are actually designed today. But we have seen this accomplished by a few advanced IT and application teams within the enterprise and service provider community. But I think this will be common going forward, and it makes a lot of sense. Now, new tools are emerging to facilitate this cloud bursting for enterprise-grade applications, and application delivery vendors are building tools now to really automate the orchestration of the application flows between these cloud environments. So as we look at this example, Jim, we have traffic that is directed to the on-premise data center or private cloud, but when there's a certain compute capacity threshold that is reached, the instances of the application can be spun up on the public cloud. And again, I've seen this with a few providers, service providers in recent history, that it just made sense to do this because the idea of just purchasing additional equipment, the idea of over-provisioning, just did not make a lot of sense. So by working with the application, setting up some communications between either the private cloud and the public cloud, they can redirect traffic to burst as needed. And that's a very cost-effective method. Now, again, the nice thing about this, or the advantage of using the public cloud, really is that the resources are just used when needed and paid for as needed. And this approach will allow businesses to not, as I mentioned, over-provision the data center or the private cloud, but still have this additional capacity available when it's actually needed. All right. Now, looking at our last use case, and this is really just kind of a view here and the future, what we'll be seeing with this whole idea of a multi-cloud architecture. So taking a look at this example, this would really have the idea of a cloud controller as an orchestration entity. And that would take care of policy, management, and analytics, and all that would be centralized. And some examples of what this controller would do would be initiate workflows, push global server load balancing policies, provide predictive analytics, and do things like optimize cost based on a cloud provider at really any given time or by geography, and then manage traffic and workload conditions. So as we look at this illustration, this example, we have three application tiers. Again, the web interface, the application, and a backend database. Now, based on learned or programmed analytics, the controller then, using this information, can migrate services between the cloud environments to reduce cost, to optimize performance, distribute workloads properly, and really to provide maximum application availability. So as you can imagine, there's a lot of intelligence, a lot of information that needs to be collected. But when you think about all these factors that are out there, as I mentioned, the cost of the infrastructure at any given time, the cost of maybe a cloud provider based on the country or the region, they're going to change and they're going to be different. So by having this entity either learn this information or at least provide the ability to be programmed with this information, intelligent decisions can be made about pushing applications and their application delivery services as needed. And Jim, I don't know if you have any comments on that, but I think that's a very great example of the idea of a multi-cloud environment.
Absolutely. Yeah. Just maybe one quick question. It's interesting because I like the way you've broken this down. You've kind of broken it down into web interface, application, and database. So, but I'm assuming that if an operator wants to, do this migration, that they actually have to sort of have a strategy from I guess involving all the tiers, so basically migrating the web interface and then the application and then the databases. How does that work with an actual sort of cutover? Do you have to do kind of them sort of in lockstep, or is there some sort of, is it really a different process that every operator can follow?
Well, I think to the latter point about the different process they can follow. Now, this is a nice example of what's going to be done, and we'll kind of look at this more in the future. As you can imagine, Jim, based on your question, there's a lot of information to collect, a lot of information to analyze, exactly, and decisions to be made, and that's really on the business side. Now, clearly any business would think that, hey, if I could save money by migrating from one public cloud to another, if I have some sort of performance issue and I need to push something back to a private cloud that I already own, that's a really good thing. Now, on the back end, as you just said, Jim, that's not something that just magic happens and everything just seamlessly moves over. There's going to be a lot of coordination. And I think when we talk about integrating the application delivery, we talk about this cloud-native applications, there's a lot of centralized intelligence. So I don't look at this as the old, multi-tier model that you have your network equipment, then you have this load balancer, and then you'll have these applications that are independent. These are really starting to intertwine together, sharing information, and we'll talk a little bit about the use of the APIs to collect information. So Jim, to kind of answer your question, there'll be a lot of coordination between actually what's programmed and these applications themselves to make that happen. But that certainly can happen.
But generally speaking, would it be fair to say that you would kind of start with the web interfaces and the applications first?
That would probably be a fair statement, no doubt. Okay. And again, this is just kind of a glimpse in the future. I did not want to downplay the complexity, but I think the point being is that this whole architecture that I mentioned about multi-cloud, by having a controller collect these analytics and allowing these factors to be put in place, this is the point that we'll get to. And obviously that would be much more seamless than doing something manual today, which is very difficult to do.
Right. And that's another point that you're going to talk about in a couple of slides, and that's kind of because of this sort of multi-tier migration process, that's kind of the value of analytics is there as well. So I won't steal your thunder, but that's obviously something that I think is important.
Okay. Absolutely. Okay. Absolutely. All right. So let's move on, and we have this concept now. We talked about on-premise and the public and private clouds. Now we have this concept of ADC as a service. And as we looked at some of these use cases and why organizations are moving applications and services to the cloud, the ability for the virtual ADC to spin up and down quickly, provide secure, elastic delivery of applications is critical. So the model of an ADC as a service can allow organizations to provision services faster, can automate functionality, distribute traffic across different environments. And the return on investment can be recognized faster by business because they are only paying for what they use, which is accomplished by flexible licensing options. Now, Jim, as you know, and hopefully some of the folks on the webinar know, A10 Networks recently acquired a company by the name of AppZito, who has developed a cloud-native application delivery controller and provides a software-as-a-service ADC solution. And combining this with A10's product portfolio, A10 will now be able to offer customers with on-premise, public and private cloud, or hybrid secure application delivery solutions. And the AppZito technology addresses the evolving requirements of the new microservices and container application architectures. And this technology can be consumed very easily, again, as a software-as-a-service model. Now, if I just want to take a moment and just talk a little bit about this new AppZito platform that's being integrated into the A10 portfolio, the AppZito platform separates the control and data planes and allows each plane to be scaled out as needed. And it's really a multi-tenant, multi-cloud controller-based solution that allows for separate tenants, where developers can create their own applications and utilize self-service capabilities. And this is all built for microservices and the container environment. Now, it offers both lightweight load balancing and traffic managed capabilities based off of Nginx. And this allows for scaling up and down that can be embedded into the microservices architecture. Now, it's modified to integrate with DevOps processes to make it more efficient, and also provide security functionality, such as a web application firewall and some DDoS mitigation capabilities. Now, as far as the functionality, the AppZito solution is much more compelling and powerful than just using an open source ADC like Nginx or HA proxy by itself. So the controller will orchestrate and centrally manage the application delivery proxies and allow the process of delivering application delivery layer to be much more simpler regardless of the location. Again, the self-service portal will be provided, and it's allowed the application team to actually spin up their own infrastructure and apply their own policies. And the solution is programmable through a RESTful API, so it can integrate with the various DevOps tools. Now, the controller will also have the capability in the near future to manage other products, such as A10's existing vThunder ADC for additional advanced application delivery features. And again, it'll take care of multiple environments that would be on-premise, public clouds, and private clouds. Now, the solution's traffic management capabilities will include both Layer 4 and Layer 7 load balancing and traffic redirection support. As an example, redirecting test and production traffic from different cloud environments. And the solution will also provide deep visibility and analytics through dashboards, which I'll give you an example in a moment. And this will assist in optimizing application performance, security, and capacity. Now, most public cloud operators today provide network layer security, but this solution will provide application layer security. As I mentioned, web application firewall, black whitelist, some bot detection capabilities, and the ability to allow for third-party threat detection integration. So by combining A10's current ACOS vThunder innovations along with the new AppZito controller and lightweight proxy, A10 has a comprehensive solution to really address the private cloud environment. And we talked before about the public cloud environment, but when we look at the private cloud now, we're talking about a controller in the system that can really work in all environments, again, just to make sure that policy, security, the actual application delivery is very consistent across these different environments. All right, now, let's just cover the actual multi-cloud architecture itself. So this is really just a snapshot here of just the multi-cloud architecture that really provides the framework for a lot of the different use cases that we spoke about and some of the different features that I had mentioned. So in this architecture, an admin can manage both a lightweight or a heavyweight application delivery proxy through a centralized cloud services controller. The application delivery engines themselves, the actual virtual load balancers, will run directly on the various public and private clouds. And the integration with automation and development tools will all be performed through an API. So all policies are centrally managed on the controller, and that will allow specific policies to be applied to a service across all cloud environments. So again, it doesn't matter if it's a public cloud, private cloud, or both. We'll have very consistent policies, all managed and controlled from one entity. And again, the application delivery and security services can be deployed to multiple clouds in one single step. Now, the centralized controller will align communications between the clouds, and it's obviously very important for some of the use cases we just spoke about, and allow these services to be migrated to different environments as needed. And again, this controller entity can be deployed either on the cloud or on the on-premise data center. So really customers will have the option of where they would like to manage the actual services for the application delivery. And the ability to manage separate and test production zones on the same or different cloud environments can also be performed. So the solution provides multi-tenant support, so a service provider can actually implement different environments for customers for different individual application development and services. And again, this can all be done on a single self-service portal. So based on the application workload, the controller can spin up or down application delivery services on demand. Now, just finishing up with some of the framework here of this multi-cloud architecture. So the overall cloud application delivery solution really should include a few components. One being the cloud services delivery, the management and analytics that, Jim, that you just mentioned earlier, which is so important, and then also the whole ecosystem partnerships and integration with different vendors. So if we look at the cloud services delivery, again, flexible software licensing should be able to provide prepaid, postpaid options. Subscription services should be based on either a unit of measurement, such as consumption, a rate, or a duration. So again, I think it's important, and Jim, you had mentioned this earlier, really allowing customers to have flexible deployment solutions is really based on the type of licensing that's available to them. And the goal is that the customer then can just pay for the services that they need, not buy up front and have that over-provisioning problem. And a cloud portal should be available for any of these licensing options that I mentioned, for billing, and for really onboarding services. And then this framework can support future services. We're mentioning ADC as a service, but when you think about it, Jim, we can have global server load balancing as a service, maybe additional security features like web application firewall as a service. Other things can pop up in the future that could be very well utilized or consumed with this particular model.
Right. This is a good slide for me, Brian, because I think it really kind of hits at the heart of today's presentation, and that is that the future delivery model, whether it be public or private, there's a lot of commonality, and that's kind of what you're showing here. Is kind of you're saying really that the future of cloud services, the future of delivery of cloud services, really comes down to I guess using ADCs on a number of different levels.
Correct. All right. Now, as I mentioned, the second component to this would be the management and analytics with that. So if we look at the management, we're going to want to utilize a multi-cloud controller, again, that recognizes public cloud, private cloud, and even on-premise application delivery, and really has the ability to orchestrate application delivery between these different cloud or on-premise environments. Management should also allow for auto-scale and scale-out functionality, such as multi-device load balancing. So again, Jim, as more traffic, there's more demand onto the application delivery should have that capability to scale as needed and do this dynamically. Should also provide centralized policy and configuration that I mentioned earlier, and then provide an open API for integration with third-party tools. And then we look at the analytics, we're talking about per application statistics. And we're, again, right down to the application itself, performance monitoring, capacity planning, and predictive and machine learning. And Jim, as we went through that last use case with the real-time migration, you can see the advantage of collecting a lot of analytics and then having the intelligence to actually make some decisions. And finally, if we take a closer look here at the analytics and visibility, I just provided a sample dashboard that would be available, and obviously these would be enhanced with more and more information as we go forward. But as applications and service delivery move to the cloud, many of the tools that the IT and development teams are accustomed to having may not be available in this open source environment or using an open source ADC. So it's important that the application delivery solution provides the visibility to the application performance by gathering request and response metrics to provide end-to-end user response times, referring to a user going to the application and then back to the end user. And the controller will need to provide deep, rich insight into the application traffic and provide optimization across the entire solution. And again, that would be application statistics, response times, performance in the applications, and even geolocation information. And this data can be used to verify the application performance to make sure it's consistent over time, or after a code upgrade, or for just general capacity planning. And if this is not the case, then these issues should be able to be easily identified using the available information through panels like what's being showed here today. And then finally, Jim, I thought it was very important to mention this whole idea of the ecosystem integration and partnerships. Now, application delivery vendors need to offer solutions that include advanced feature sets that have features that may not be available in open source options today, provide advanced functionality, but they also need to embrace open source components and tools. And vendors should allow their solutions to easily integrate into the DevOps tools and services to make sure that customers and developers have the tools they need and can work really hand in hand with this type of integration. And the application delivery vendors need to continue working with partners to provide deeper integration into cloud, SDN, and the microservices architecture. Now, finally, just taking a quick look at the A10 portfolio. Now, A10 has been offering application delivery solutions for quite some time now, and we already have all the products required for on-premise, public, and private cloud. But adding this controller functionality to the portfolio is very important because now we can add another option for customers to utilize application delivery as a service. Now, our portfolio will range from high-performance physical appliances with hardware offload to software-based products in VM and bare metal form factors. So we have all the various products in different form factors to meet these different environments. And again, with the whole idea of having a controller to add yet another way to consume application delivery. And these products, again, can be used in traditional and virtualized data centers, private cloud environments, integrating with platforms such as OpenStack and VMware, and along with public cloud support for Amazon Web Services, Microsoft Azure, and CenturyLink Cloud. So the A10 Appsito portfolio introduces the concept again as application delivery as a service. Now the controller, which I mentioned, that can reside in the cloud or on-premise, when you think about it, is really managing pools of resources versus individual instances in the cloud. And it will continue to evolve to manage lightweight, the Nginx ADC proxy, and a more heavyweight ACOS ADC offerings that A10 has been providing. And again, all this is completely API-driven and provides industry-leading scale, performance, and complete manageability. So A10's cloud vision is to deliver secure application services that are cloud-native and easy to consume across different types of application infrastructures, whether it's on-premise data centers or virtualized data centers, as well as public and private clouds. And A10 is trying to help organizations bridge between on-premise and cloud environments by offering managed application delivery solutions that provide multi-cloud capabilities for infrastructure-agnostic flexibility. So, Jim, I appreciate your time just to provide a quick overview of the A10 portfolio, and let me turn it back over to you.
Okay, great. So thanks, Brian. So interesting presentation. So maybe just in terms of before we get to the Q&A, and we're going to conduct one more poll question, maybe I'd just like to maybe summarize some of the points that you and I made in this presentation. I think it's important. There's some important takeaways, I think, for the audience in today's presentation. I think the first is that application delivery in terms of security solutions, because of the hybrid environment, the public or the private cloud. And I really like the use cases that you showed that you can actually use both public and private in a hybrid context. Because of that, there's really a need to provide these multi-cloud capabilities, and that's really something that the ADCs need to be able to support going forward. And also, I think as you talked about and I talked about, really application delivery and security really needs to provide the same sort of, interface and configuration management and analytics, whether it's on-premise, public, or private cloud. That was clear in your use cases. And also, this is something we could talk a little bit about. Automation and orchestration through an open API is required to really eliminate manual processes. Because when you get right down to it, I think one of the key points I took away from one of your slides was that automation is all about simplifying processes, but to manage or to implement automation, you also need to be able to orchestrate. So, and I think that's the orchestration part of that, kind of where APIs are really key to that, right? So if you think about orchestration, and I think another key point that we both talked about is that as we move forward in terms of applications, just the very concept of how applications, especially if we move to microservices where there's some reuse capabilities and third-party software, the APIs have always been important, don't get me wrong, but I think it's even more important as we move to, the evolution of APIs becomes even more important as we move to open source. You talked about DevOps, but a lot of this really gets driven by the fact that you want to be able to implement this and test it and kind of go back to that use case you had in terms of the beta release. You don't want to have to go back and rebuild everything. So to me, I think this part is really important as well, and clearly ADCs play a key role in utilizing open APIs, but also using them to facilitate automation and orchestration.
Correct.
Okay. And I guess also you've talked about some ADC services as well, ADC as a service. That was kind of something we talked about. I think that's really important because it really, I think, provides customers with these flexible deployment and pricing options for service agility. And then finally, you provided an overview of A10's application delivery solutions and kind of your strategy and how acquisitions have tied into that to kind of be able to provide your customers with the basically kind of, I guess, an architecture, a generic architecture that's really designed to support public and private clouds and on-premise ones.
Right. So Dave, if I just step back a couple of points, as you just mentioned with the ADC as a service. So really this is, as I mentioned before, just a new way for users to consume application delivery services.
Exactly.
And you think about what has traditionally been done with application delivery over the years, using physical products and kind of moving to virtualization. As we see the benefits of the public cloud and how well it's being adopted, the idea of just paying for the infrastructure as needed is very powerful, and I think we can see that by its use. So the idea of ADC as a service really is not that far-fetched to come and play today, because again, it just makes sense. If you're going to pay for an infrastructure as needed, why not pay for application delivery as needed, versus buying something and pushing up the cloud and then, again, dealing with licenses and the normal support costs that customers have been traditionally paying.
Okay, perfect. Okay, well, excellent presentation. So let's take some questions now, but before we do the questions, I also wanted to conduct 1 second poll question. And we talked a lot about, in the second half of the presentation, about implementing application-based analytics, and it's obviously a hot topic for good reason. So the question for the audience is, what is the key driver? What do you consider the key driver for implementing application-based analytics? Is it predictive learning? Is it performance monitoring, enhanced troubleshooting, or proactive security enforcement? So actually, Brian, while we're waiting for the audience to provide input, let's go back to one of the use cases you talked about. And one of those was scaling and workload bursting. That was a use case that was interesting. And you talked about how, in a previous use case, it could be kind of a 20 to 30% staging and testing savings by not having to do all those beta releases and so on. Just wondering, are the savings, though, in just the context of pure scaling and workload bursting, in that use case, are those significant savings as well?
Yeah, absolutely, they can be. Now, that's really going to be dependent upon the business itself, obviously. But when you think about it, it really allows organizations to not over-provision. So, again, the whole thought of just paying for services as needed, I think, is very important. And I think when we talk about the workload bursting, the ability to have that available and then pay as needed is much more powerful than buying something that you might need going forward. So really depending upon the size of the business, that savings can be significant.
Okay, great. Okay, so let's just see what the audience said here in terms of the results. Interesting. Okay, so pretty much, I would say pretty even. So performance monitoring, 30% was kind of the number one, I guess, and then close behind, pretty much a tie, enhanced troubleshooting and predictive learning, and then the final one was proactive security enforcement. Any surprise from your surprises here from your perspective?
No surprises. So if we take a look at these, Jim, so the performance monitoring, the enhanced troubleshooting, security enforcement, these are things when I look at these responses that if folks are used to handling these and having monitoring, troubleshooting tools, things like that on-premise, then as they move to the cloud, especially the public cloud, you want to have those tools available. So exactly. That makes sense to me for that. And I thought it was very interesting that 26% mentioned the predictive learning. And I think, as I indicated earlier, by having solutions like the centralized controller that's collecting this information, analyzing these analytics, that can be very powerful for some of the use cases that I mentioned before. And when you think about the business drivers, I think going forward, I think you're going to see more and more of those use cases being used on a regular basis.
Yeah, absolutely. I totally agree. And part of that is just because, like I said, we talked about at the beginning, the reason for that is the applications that are going to be hosted in on-premise or private or public, they're changing dramatically. And a lot of that is you need predictive learning to be able to understand sort of the performance and also sort of the demand for that application.
Yeah, absolutely. So I'm not surprised. I'm pleased to see that at least a quarter of the folks on the call felt that was important.
Good stuff. Okay. So we're going to get to more questions, but before we do, we've got about 5 minutes left. I just want to push out to the audience this URL for you to provide feedback on today's session. As we said at the beginning of today's session, your feedback is really helpful to us to plan future sessions. So if you can take that now, take that link and provide input, it would be much appreciated. So maybe I guess there are a couple of questions. Let me go through them. I'm just going to go through the questions from the audience. maybe I'll kind of paraphrase. Does the addition of a self-service portal add any additional security requirements?
Okay, so I think when we look at this, we're talking about the self-service portal, and if I'm logging into, say, a controller that's sitting in a cloud, there may be concerns, if I'm understand this question properly, regarding security. So I kind of look at, Jim, that first off, we'll have security in place. So obviously this would be the kind of equivalent if you just took a virtual load balancer, you push this out to a public cloud, you wanted to configure the load balancer, you wanted to get some statistics from it, obviously there's going to be a certain login. So that's not going to go away by any means. And we'll be announcing some of our options for security as we get into the controller either sitting on the cloud or on-premise. But I assure you that will be as secure as just logging into a load balancer that's already secure that's sitting in the cloud.
Okay, perfect.
Hopefully I answered that question properly.
Yeah, for sure. This question is a bit more about an application failure scenario. Again, I'll kind of paraphrase it. It's like basically if an application is running cloud natively and it fails, can the ADC or the controller, can it use on-premises resources in the data center, or does failover have to take place in the cloud?
Okay, that's actually a very good question. So I think there's two ways to look at that. Now, as of today, if we don't look at the central controller-based architecture that I just mentioned earlier, you're going to have the same sort of redundancy in a cloud. So when customers of A10 were looking to run virtualized load balancers in various public and private clouds, they're going to have separate applications running as VMs, and they're going to have separate load balancers running. So obviously this would be more of a logical failover within a cloud. But that whole idea of having a backup load balancer and still monitoring the applications, all that still exists today. So I would have to say that you would want to fail over within a cloud if possible. Now, if there was some problem within the cloud, unfortunately, the cloud was taking on some sort of volumetric attack. There was issues about access to the particular cloud as a kind of a example. The ability with that controller to look at the resources, look at the application health within a certain cloud, and redirect to either a private cloud or back to an on-premise data center would obviously be the case. And then that can extend a little bit to we were talking about the disaster recovery and some of the other use cases. But I think, again, with the whole architecture of a controller that's looking at all environments at the same time, that would be another option that you could go from one cloud environment to another or back to an on-premise data center. Okay,
great. Maybe we've got time for one more question. This question is all about licensing. So you talked about flexible licensing. Does by implementing flexible licensing, does that really kind of change how the customer would contact or contract with third parties for cloud services? Or I guess the question really is using a virtual ADC controller, does that change kind of the business relationship with that cloud service provider that an operator might have or a service provider might have?
That's a very, very good question. And we'll have some announcements as we start to offer these solutions here in the fourth quarter and early next year for both public and private cloud delivery as a service. But if I'm answering this correctly, right now that would be a little bit separate about having your resources, your contracts available, or resources, I should say, within, say, Microsoft Azure or looking at AWS. And this should be fairly transparent with your application delivery at this time. Now, the thought of some other integrations in the future, obviously that could happen. But when you think about it, as we're talking about utilizing different cloud providers, different environments, I think the real goal here is to make sure that you're somewhat independent. You want to be integrated, but you want to have the flexibility to move to different environments, and whether it being public, private, or on-premise.
Right, I agree. And I guess also maybe a point I would maybe add to that is I would think that licensing or that business model kind of changes or can change based on that three-tier. You had the web interface or the application, and then the application. And the database kind of depends on to which level of all three you change, I guess.
That would be correct. So there's a lot of factors there, and I think things may change in the future, but now I would kind of look at that as being somewhat transparent to the actual cloud provider. You want that flexibility to use the provider that's best suited for your applications and environment.
Okay, perfect. So we're going to have to leave it there. So I'd like to, first of all, thank Brian and A10 for presenting today's content and sponsoring today's webinar, and also like to thank you, the audience, for attending our session today. So on behalf of Light Reading, this is Jim Hodges. Thank you for attending today's session. We hope to see you again soon. Thank you.
Okay, thank you, everyone.